All right, good morning, everyone. Today, taking a look at actually completing this square. So, kind of a continuation of what we talked about yesterday. Okay. Um, so, all quadratic equations, so all quadratic equations can be solved using the square root property by manipulating the equation until one side is a perfect square. Guys, this method is called completing the square. All right. So, guys, the idea is if you take this equation, x squared plus 16x equals 9, and you make this left side a perfect square trinomial by figuring out what value is needed there to make it a perfect square. In this case, well, in all cases, the way you find that out is you take the b term, divide it by 2, and then square it. So 16 divided by 2 in this case is 8. 8 squared is 64. So, guys, as you know, if you are adding a number to one side of an equation, you've got to do that to the other side. Okay? So you can't just throw a 64 onto one side of the equation and it stay balanced. You've got to add 64 to the other side. Okay? So doing that, adding 64 to both sides, keeps the equation accurate. And then it allows you to write the left side as x plus 8 squared equals 73. And then you can solve it using the square root method or square root property that we used yesterday. So the main takeaway here, guys, is find 1/2 of b, which is going to be the coefficient of x. Okay, square it, and then add it to both sides. Okay, so b over 2 squared. And then you're going to add that to both sides. Okay. So just a little bit of practice with this. Okay, so what value of c makes this a perfect square? Okay, so what value can we put here to make this a perfect square? Okay, again, that process is take your coefficient of x, divide it by 2, and square it. So in this case, this is like the example we just saw at the top, guys. This is 16 divided by 2 is 8. 8 squared is 64. So 64 is going to be that value of c that makes this a perfect square trinomial. Guys, then write the trinomial as a perfect square. So write this as x plus, multiplies to 64, adds to 8. Guys, adds to 16, I'm sorry, will be 8. Over that 16 divided by 2 is 8. Okay. Next page. All right, guys, another one of those examples here. Okay, so what makes it a perfect square? Again, taking that middle term, in this case it's a negative 14 over 2 and squaring it. Negative 14 over 2 is negative 7. Negative 7 squared is 49. So c would be 49. Okay. Writing it as a perfect square should be x minus 7 squared. Guys, you can solve any quadratic equation by completing the square. Okay. So what does that look like? Okay, obviously this left side is not a perfect square. So let's move the 11 to the right side. We got x squared plus 10x equals 0 plus 11 is 11. Okay, let's add something to this left side to make it a perfect square. If we add it to the left side, we also have to add it to the right side. Okay, so what number is going to make that left side a perfect square? Just that same process we've been doing. 10 divided by 2 is squared. I guess it's 25, so you're going to add 25 to both sides. Okay, so this left side of the equation, that's going to become x plus 5 squared equals 11 plus 25 is 36. Okay, square root both sides. we've got x plus 5 equals plus or minus 6. Subtracting 5, we've got x equals negative 5 plus or minus 6. Negative 5 plus 6 is positive 1. Negative 5 minus 6 is negative 11. So your solutions are 1 and negative 11. Okay. There's a couple more examples of this. I'll do 4a and then I'll leave 4b for you guys. So 4a, what's that look like? Again, I'm going to subtract the 24 over, which is going to leave us some room to make this left side a perfect square. All right. So to make that left side a perfect square, we got to, negative 10 divided by 2 squared. That is negative 5 squared is 25. So we're going to add 25 to both sides. Left side, that factors to x minus 5 squared equals 1. Negative 24 plus 25 is 1. Square root both sides. X minus 5 equals plus or minus square root of 1 is 1. Adding 5. So 5 plus or minus 1. 5 plus 1 is 6. 5 minus 1 is 4. So 6 and 4 would be our solutions here. Okay. Leave you guys 4b there. Guys, onto the back side, or the next side of the notes here, the next example. We do get a slightly tough problem. Problem is not quite as easy. Solving by completing the square. This problem has an equation with a leading coefficient other than 1. So the way you're going to deal with that is divide everything by 2. Okay, that's going to leave you x squared. The 2's cancel. Negative 7 divided by 2 is negative 3.5x. And then plus 2.5 equals 0 divided by 2 is 0. You guys going to complete the square of this left side. So we're going to get rid of the 2.5. All right, so to find, what we're adding to both sides of this, we're going to go negative 3.5, and we're going to divide it by 2 and square it. Guys, give you a minute. Use your calculators. That's going to be negative 1.75 squared, which is 3.0625. Not doing any rounding yet. So that's what we'll add to both sides. Okay. That is going to give you x minus 1.75 squared. That's what that left side is going to factor to. And that 1.75, that comes from, your b term divided by 2. Equals, I think this is 0.5625. You're going to square root both sides. Because the square root of 0.5625 is 0.75. So I knew that would work out nicely if we didn't round. So a little bit of a cheater there on my part. Okay, so 1.75 minus 0.75 is just 1. And then if we add 0.75, we would get 1.75 plus 0.75. We got 2.5. 2.5. Okay. So 1 and 2.5 would be our solutions there. Okay. Guys, 3 is going to be very similar. You're going to divide both sides by 3. Or not 3, I'm sorry, 5a is going to be very similar. Divide both sides by 3. And equations with imaginary solutions. I did want to show you guys one of these. So the situation here, we're going to be using the same method here. We're going to add, so 8 divided by 2 squared, so 4 squared, 16. We're going to add 16 to both sides. Okay, this side becomes x plus 4 squared equals, well, negative 22 plus 16 is negative 6. Okay. So when we go to square root both sides, guys, if we're square rooting a negative, this is where that imaginary number work came in. This is actually I radical 6. Okay. Again, thinking of that as the square root of negative 1 times the square root of 6. All right, and plus or minus, excuse me, I forgot to put the plus or minus. So we'll subtract 4, guys, leaving your numbers in a reduced radical form is going to kind of become the standard here. So leaving radicals in your answer would be fine. We're not going to continue down with decimals and things like that. We'll just simplify as best we can. All right. So I think you guys have seen an example of each. Video's kind of getting a little long, so guys, haven't had a lot of questions the last couple of days. I know this material can be tough, so if you do have questions, again, I'm posting discussion boards. You guys can email me. You can Canvas message me. My goal, again, is to help you guys make this as easy as possible for you. So however I can help you, let me know. All right. Everyone have a wonderful afternoon. Remember, tomorrow, no new content, just kind of reviewing these concepts. So, all right, thanks for watching, guys. Have a good one.